Alright, this is video 15 for College Algebra, and we're going to be talking about polynomial functions today. So first we just need to look at some vocabulary. So first of all, the degree is the highest exponent. So with our example here, the highest exponent would be 5. Okay. The coefficients, those are the numbers in front of a variable. So we actually have 5 different coefficients. So we have 3, 6, -2, 1, okay, there's a 1 in front of that x, and then 7. A constant is the number without a variable, so our constant here is -6. Our leading term is the term with the highest exponent, so that would be 3x to the 5th. You include the coefficient and the variable. And then the leading coefficient is just the number in front of the leading term. It's the coefficient of the leading term. So when we look at graphs of polynomials, they're smooth curves, they have no breaks, and no sharp points in them. So if it was a roller coaster, you'd be able to ride it smoothly. And multiplicity is how the graph behaves at each 0. So if something has a multiplicity of 1, it's just going to cut straight through at that 0. All right, if it's a multiplicity of 2, it touches the 0 and then comes right back up. And I like to call this, just kind of kisses that axis and comes down and right back up. And then with a multiplicity of 3, it bends at our axis. And then for everything else, it's either going to behave like 2 or 3 multiplicity. If it would be a 4 multiplicity, it'd look like a 2, it'd just be a little wider. If it was 6, same thing, just a little bit wider. Odd will act like 3. So let's look at this polynomial and determine its zeros and multiplicities. So first of all, I can find my zeros by setting each one of these little factors equal to 0. So I've got a 0 at 0, 1, and -3. And the multiplicity is, what is that exponent with it? All right, so this one had a 2, so this is an exponent of 2. This had a multiplicity of 1. We can actually go ahead and cube this. We'll still get the same answer. And this had a multiplicity of 3. So if we wanted to, we could kind of sketch this graph. And we won't know our maximums or minimums or anything, but we kind of know what's going to happen at each graph. So I do know that I have a 0 at 0, a 0 at 1, and a 0 at 3. So 2 is going to come up, kiss through. I'm going to cut through at 1 and kind of bend. And this is not accurate at all. It's just showing what is happening at our zeros. And that's all that we're looking at. Looking at our end behaviors. Our end behaviors behave differently depending on our leading coefficient and our degree. So if we have an even degree, I like to think like a line. All right, so if it's positive, it's going to go up. If it's negative, it will go down. So in our picture, with an odd, with our leading coefficient of positive, I'm going to start down and end up. Now, it could be a whole bunch of curves in the middle, but I know this is what my ends are going to look like. with a leading coefficient that's negative, when you have an odd degree, it's going to look like this. And with degrees that are even, I like to think like a quadratic. So we're going to have either opening up or opening down. So if it's a positive, they're both going to end up. If it's negative, they're both going to end down. So let's get into some examples. For the first one, always go back and make sure that you fill out tables for your points. And you can do that on Desmos, or you can do that on your graphing calculator. If I look at my table, plug that in, hit second graph, and I have my table of values. Okay, and so from there I can plug in everything that I need to know. So at -2, be at -9, -4, -1, 0, and -1. Okay, and so from there I can graph my function. So at 0, I am down 1. Okay, and these are always just kind of approximations. I don't have to go down and graph all the way down at -9. Just graph anything that you need. So if I only need my 3 points, then that's all you need to graph. If you want to graph some more points, then you can do that as well. So here we have our graph. And we can see that at +1, it just comes, kind of kisses that axis and comes right back down. And that's because we have that multiplicity of 2, okay? So that would be our graph. But always check your Desmos or your graphing calculator to make sure your graph is correct. So now, looking at our end behavior, for this one, we have a -2x to the 4th as our leading term. So with this, I have a negative and it's an even number. So with that, my end behavior, they are both going to be down. And for my assignments, I usually take arrows of what my end behavior looks like. But then we can also write it like this. As I'm approaching infinity, so as I'm going bigger and bigger and bigger, what's happening to my y values? Well, those are also going down, all right? And so my y values are going towards infinity. Remember, f of x just means y. And then as I'm approaching negative infinity, as I get smaller and smaller and smaller, my y values are getting smaller and smaller and smaller as well. So it's a negative infinity. My graph looks like kind of like a frowny face. So as I'm approaching this infinity, my y values are going down and down and down. As I'm approaching negative infinity, they continue down. And so this is just another way of putting that. So for our next one, we have a positive leading coefficient and an odd degree. So my end behaviors here will be down and then up. So as I'm approaching infinity, my y values are getting bigger and bigger. As I approach negative infinity, my y values are getting smaller and smaller. All right, and here we're actually going to find all of our zeros and just kind of look at our graph. So first of all, we need to start by factoring this. So we can set this equal to 0, and let's go ahead and take out a GCF of -x squared. All right, and from there we can factor even farther. 2x squared plus x minus 3. Remember, we can do our little x factoring. We're trying to multiply to -6 and add to 1. So that's going to be 3 and -2. So I'm going to have 2x plus 3 and 2x minus 2. This can reduce. I can divide by 2, and so I get x minus 1. My 2x plus 3, I can't do anything with that. So I've got 2x plus 3 and x minus 1. So if I set each one of those equal to 0, I can find my zeros. I've got, I got to find 4 zeros because it's a multiplicity of 4. So here I've got x equals 0, x equals negative 3 halves, and x equals 1. Well, that's only 3 zeros, but this x equals 0, that has a multiplicity of 2. So we've got 0, and we can say multiplicity of 2, negative 3 halves with a multiplicity of 1, and 1 with a multiplicity of 1. My end behavior, since it's a negative and even coefficient, they are both going down. So let's plot our zeros. I've got one at 0, positive 1, and negative 1.5. And both of these are going down. Now, since at negative 3 halves, it's a multiplicity of 1, it means it just cuts on through. At 0, it's going to come down and kiss and come right back up. And at 1, it's going to cut right through again. So we can always look at our graphing calculator to get the exact minimums and maximums, but what we really care about is what's happening at each 0 and our end behaviors. Another thing to know is the number of relative local minimums or maximums, okay? And relative just means they're not at the very ends, so they're locally in the middle of our graph. It's equal to, or you could call it the max number of turns is the degree minus 1. So our degree for this is 4. Well, I have 3 turns, 1, 2, and 3. All right, for our last problem, given our zeros, we want to write a polynomial. So it's got given our zeros, and it says all with a multiplicity of 1 except for 3. Let's say 3 with a multiplicity of 2. So the easiest way to write this, you can say y equals, let's change this to p of x for a polynomial. All right, so it's just the opposites of these, because remember, to find these, I would put that x plus or minus something equals 0. So to get negative 1, that'd be x plus 1. To get a negative 3, x plus 3. To get a 0, that would just be x. Get 4/5, that's a little more tricky, but it's 5x minus 4. Now it says all of these have a multiplicity of 1 except negative 3. That has a multiplicity of 2. So that would make this have a square. If I had a multiplicity of 3 of one of these, I'd put an exponent of 3. Okay? So this is just our basics of graphing our zeros with different multiplicities and looking at our end behavior.